Video number 1 for RMA number 18-120 or 18120 for electronic and engineering designs. And here we have a 6100 board REV K, and we're going to show briefly how to verify that everything is working okay, and more importantly, with the use of an oscilloscope, how to check that we have all 6 SCRs. For this part of the test, we need power. We're going to be able to control the board by enabling and inhibiting, and we also need a phase reference. So let's go ahead and turn the 120, power the board through the transformer. With nothing else on, we see that we have the green LED and we have the 2 LEDs, the inhibit LED and the phase loss LED. Now, by powering this box, what we're going to do is we're going to fake the phase reference signals that will clear the phase loss. And can we inhibit the board, Tony, so that when it comes on, it inhibits? So let's go ahead and power on. I'll go ahead. Now, what we've done is, because we have the phase reference, we have the correct phasing, the phase loss LED, it's off, and now it's a matter of toggling a switch, or in this case a button, to enable the board and to turn it on and off. Go ahead, Tony. So we have now, under normal conditions, we have a green LED showing that we have 12 volts, and the 2 LEDs are off. You don't have a phase loss, and the board it's already enabled. What we do is, and we have connections here already in previous connection diagrams, we're going to vary the delay angle command. Can you have a meter on seek high, Tony? So there's seek high is J3 position 10. We are at 0, and Tony is going to start increasing that until we go to 5 volts. Appreciate if you can stay there. And we notice there, well, here we're going to be able to look at the output. This is one of the outputs. We'll show that last, but this the yellow channel, we're looking at the 60 hertz, and that's on test point 5. That's a reference. And then on channel 2, that's our delay angle on test point 3. We have here, through the scope, we are measuring the phase displacement between the two, and with 5 volts the displacement is 11.6 degrees. Basically, we are measuring the displacement between here and here. Now let's go ahead and change it, Tony. Go ahead and start decreasing. Now without we decrease, we're going to look at and we notice here that this delay angle starts increasing again from that age to here. Now at 0, this delay angle is 143 degrees. This is the delay angle range that we recommend for a rectifier. So again, can you go ahead and go 0 to 5 again, Tony? We see the delay angle will start decreasing, TP3 with respect to TP5, and we notice that here we have the output. Now the output is selected right now for which output, Tony? Number 1. Okay, so that's the 8+, that's number 1. Let's go ahead and take a look at the second one, the third one, and we can see the 120 degrees of placement, fourth one, fifth, and sixth. Obviously, in order for you to check all at once, you would have to have this test box, but you don't have to have, as long as you bring in power through J4, as long as you bring in the phase reference through either J7A or J7B, as we'll show in a second video, and as long as we have the enable and the 0 to 5 signal, you can make the board enable. If you have an oscilloscope, what you can do is, let's remove J1 and J2. Don't worry about the amplitude. All you want to do is just have your oscilloscope probe, use the ground clip, verify that that's all isolated from the board, and then have on the cathode and the gate, and you will see the 230-degree outputs. So we're looking right now at the plus a SCR output between J1, it's the gate, between 2 is the cathode. The gate, it's where the probe is. The cathode, that's where the grounding clip is. And there it is. So if I ask Tony to go to J1 positions 4 and 5, we will get the second one, and then if he moves to the next one, there it is, and then he can go to the next one, and so forth. Right now this is taken at 2.5 milliseconds. It's a times 10 probe, and it is a 10 volt per division setting on the scope. But at least if you see this, again, you're not going to have any control over the amplitude, but you can verify that your 6 outputs are healthy because you will have the same signal traveling in time, but they will be there. This is the end of this video.